Opposing Gloves here, and today we're going to talk about tempo. What is tempo to us in the MIDI land? So we talked about the staff last time and how we needed a unit of measurement, and the rate at which we read this unit of measurement is called our tempo. So if we have, like right here, if we had our tempo right here as something fast, so let's put down 4 notes. Let's just do an example. It's the easiest way to do this. I'm going to make these higher. So if I put down 4 notes and we're playing them at a rate of 120 called beats per minute. And there's a whole bunch of other things that we'll talk about as we get further into this. But right now, this is being played at that rate, right? Well, if we slow down the rate at which we read it, the same information can represent much longer values, which to us is a very, very important thing. It's sort of what makes genres the speed they're at. So that's tempo. That's like it. That's what you need to know about it currently. As we get more and more into it, you're going to be moving it around. But as far as making like decisions consciously about tempo, you're generally going to want to think about this at the beginning. Now, sometimes when you like, for example, let's say that you're writing something that's really fast. Well, you could choose to write it at a slow tempo with a lot of notes. Like you could write out all these itsy bitsy notes, like to try and make it fast. Or you could write it at twice the speed with half as many notes. So you could write it so it's going twice as fast. So it'll take up more measures to write, but you'll be able to write it with less notes, which is the way that people generally like to think about it, because it's easier to read 4 measures of quarter notes at 220 beats per minute than it is to read at a whole bunch of 16th notes at 110. Or what is it, quarter notes, so it'd be 8th notes, so it wouldn't be that bad. But anyways, so you can finagle things around to make them, I'm not sure how accurate my example I just gave was, but I'm just giving an example of like, there are different ways of looking at the same problem, and the majority of people are going to want some sort of a middle ground where things aren't as fast. Now, we're in MIDI land, so it doesn't particularly matter to us, but it's going to change the way we perceive things on the piano roll. If you've ever opened up a Bach MIDI file and looked at the amount of notes in like one measure, it's kind of a scary thing. But then you realize it's at 80 beats per minute and it's not near as fast as it looks. And so there's a variety of reasons we would do both, but it's sort of just a choice we make at the beginning on how we want to approach composition. And it sort of changes our mindset. It doesn't really change anything too technically, except for certain rhythms cannot be represented. They just simply won't be represented at certain tempos, because like there's a version of this same exact rhythm where if at 110 we get that, but if we skew it just a little bit, now that's technically a little bit shorter and this is a little bit shorter. So we're going to get different rhythms. So if we move dramatically, those become much bigger. And although we could come up with rhythms that are really the same, and theoretically we could come up with ways to notate things that are the exact same value, it's just not going to happen like reasonably, especially in written music. But in the piano roll, we actually probably could if we really went for it, but that's the idea. So that's why some genres sound so different at different tempos, or why genres exist around tempos, is because the rhythms that naturally occur at those speeds are dictated by the tempo. So if you have any questions, let me know. Subscribe and have a blessed day. We talked about sine waves, and it's really super important that we have to understand sine waves. Now we're going to talk about fundamental tones, because guess what? I'm going to just show you something real fast. This tone right here, let's do this. This tone has all these sine waves, right? Which one's the pitch? So that's the idea. So,